Hey everyone, here's a new tutorial. So usually in 3D design, we'll end up using a rendering plugin or an additional rendering program to apply textures that emulate real-world materials onto 3D objects. But that's a little high-tech at this point. So we're going to use a low-tech technique to wrap images around drawings of 3D objects. How good are you at wrapping?
Boom, bam, bop, bada boop, pow.
I'm pretty sure you can do better than that. Let's get started. Okay, cool. The first thing we're going to do is to construct a ground plane out of grid lines. So let's make a grid using the array command. First draw a polyline, and then use array. The array command will allow us to copy one object multiple times in one operation. In this case, let's go in the X direction. So we're going to select how many lines we want in the X direction. Let's type 10. For Y and Z, let them default to 1. And then for spacing, type 1 for 1 inch. This looks a little small, so I'm going to scale in 1 dimension to make these lines twice as long, and then I'm going to copy all of these lines to the right so I have twice as many of them. I'm going to make a copy of all of these lines just off to the left, and then rotate them all 90 degrees. Then I'm going to move them back so that they intersect with the original grid lines, giving me a grid. Depending on your results, you can use commands like copy, trim, and extend to square up the grid that you have. Notice that I'm using an existing spacing between two grid lines to reference as I copy additional grid lines. Great, there's our referenced ground plane. Now let's lock the grid line layer, disable OSnap, and disable ortho, and drag our geometry into the middle of the grid. You can line this up with the grid, snap it to certain intersections, but in this case, I'm roughly eyeballing the center of this grid. Now I want to find a nice point of view from which to make our drawing. A technique I like to use a reference cube to serve as a virtual camera. I'm creating a new layer, giving it a different layer color, and then modeling a cube to put on that layer. Now when I select this cube, and use the command ZS, or zoom selected, my camera will then zoom in to where that cube is. Then finally, by hiding the cube, I can now see what the point of view of my scene is from the cube's perspective. So if I imagine that I am this little cube, I put myself in the scene where I would like to see this geometry, zoom into it, and then I've got my point of view. After you've hidden your placeholder, you can always make small adjustments with pan or orbit. Once we've found the perfect view, it's time to make 2D. Let's create a new layer to put all these lines on, call it drawings. Select everything and use the make 2D command, and make sure all visible lines go on this new drawings layer. This command should put your drawing at the world origin. If you don't see it, switch to top view and you should see it near the world origin. Move these lines off to the side and then draw a rectangle that corresponds to the size of the paper that this drawing is meant to be printed on. In our case, 10 inches by 10 inches. Center your drawing in this boundary and scale it up. It's okay that it's not exactly the same size it was drawn at. Perspective drawings can't be to a defined scale anyways. Let's use some digital drafting techniques to fill out the rest of this foreground with our ground plane. Select the boundary of the drawing and then type extend. Now click on all of the lines that correspond with the y-axis. These should extend these lines to the boundary of the drawing. Remember the technique we used to reference an existing grid spacing to complete the rest of the grid? Well, we're going to use the same technique here, except this is more or less a 2-point perspective. As a rule of thumb, to complete this kind of grid, instead of referencing one previous grid subdivision, you should reference 2. So to know how much closer the next corresponding x-axis grid line should be to the camera, reference the previous two grid subdivisions, and then extend these to the boundary of the drawing. This isn't perfect, but it's a really good approximation. Now select the boundary of the drawing and use this to trim away the excess grid lines that you may have gotten in the copying or scaling process. Alright, now we're going to sort all of our line work into different layers so that we can give them different colors and different line weights. We're going to do this using sublayers. Select the drawings layer and then press New Sublayer. We're going to create a total of 8 sublayers, but we won't use them all. This is just good practice for a drawing template. You can name your sublayers whatever you want, but I like to name the sublayers according to the line weight that I'm going to assign to them. In my case, I like to name my sublayers 00 through 07. For the sublayer display color, I like to change these to the same colors that correspond with AutoCAD's index colors. Feel free to copy what I've done here for your own drawing templates. There are many different methods of line weighting an object that appears in perspective. We're going to use an outline technique. This means that all of the lines that define the outermost edges of my object are going to be the thickest lines, and then working inwards from there, the lines will become thinner and thinner. I'm selecting the outer and top edges of my object here. I could honestly put these lines on any layer. It doesn't really matter if I put them on layer 4 or layer 7. I just want to make sure that they are grouped in the same layer, and I can make line weight choices later in AutoCAD. The next group of lines to sort out are all the lines that describe the transition between my object and the ground plane, or all of the bottom edges of my object. I'll put these on their own sublayer. Next, I select the interior corners of my object and give them a slightly lighter line weight. And the last line I have to sort out is an edge that describes the transition between two faces, sort of an interior corner. This will be my lightest line on my object. I have one additional line here in my drawing, but it really doesn't do anything to further describe how this object looks or performs, so I'm just going to delete it. I want to make the grid lines on the ground plane the lightest lines in my entire drawing. An easy way to do this is once all of the lines in my object have been sorted, hide those layers temporarily. I can then select all of the grid lines, and in this case, I'm going to put them on layer 00. For me, this will correlate to about a 0.01 millimeter line weight. Now all the lines have been sorted. Export this as a DWG and open it up in AutoCAD. Great, now our drawing's in AutoCAD. From here, all you should have to do is set your layout and your proper CTB, and you should be good to go. But here's a couple of things that we can change to make the process a little smoother. In the Layers panel, change the layer display color to the AutoCAD index colors. The translation from Rhino isn't exact. Even though we said that layer 01 should be red, that does not correspond to AutoCAD index color 1, or red. Make sure you go through all of your used layers and change their color to AutoCAD's corresponding index color. If you want to make your own custom layout size, 10 inches by 10 inches for example, follow these directions. Change your plotter to Adobe PDF and click on Preferences. Go to Custom Properties, and under Adobe PDF Page Size, if you don't see the size you're looking for, click on Add. Give a name to this new paper size and define how large it needs to be. In this case, it would be a 10-inch width and a 10-inch height. Click Add Modify, then click OK, OK, and OK. Now on the page setup screen, you can go to paper size, and you should be able to scroll to find your custom 10-inch by 10-inch plot size. Expand your viewport until it intersects with the bounds of this layout. Then double-click inside the viewport, select everything, and then type Z enter, E enter. This will zoom your drawing all the way in to the extents of the drawing that you have. This will ensure that everything that's in your AutoCAD model space will end up in your AutoCAD layout space. Go to Export, then PDF, and you're done. Well, almost done. Now we got to bring this into Photoshop. Create a new 10-inch by 10-inch Photoshop document, and then drag and drop your PDF that you got from AutoCAD. Create a new fill layer and change it to solid white so that we can see the drawing. Awesome. Now for the fun part. Ready to wrap?
Man, every time I come and hit you with a little bit of killer, better know that you can never see.
Thanks, Busta, but we're going to do our own kind of wrapping. Drag and drop your texture into Photoshop. Rasterize the layer, and then make a copy. Press Ctrl-T to get to the transform tools, and then scale this texture down until it's about the size of the face that you would like to cover in your drawing. Lower the opacity so that you can see your drawing through your texture. Then press Ctrl-T again, right-click, and go to Distort. Drag and position each corner of this texture into the corners of each face. You can see that the texture warps as we drag these handles into the corner of each face, making it look like this texture is on that surface. Switch to your drawing layer and then use the Quick Select tool. We can use the boundaries of the drawing layer to select areas of the texture layer that we would like to delete. Use this technique to trim away the excess areas of the texture that don't line up with the surface they're attached to. Make sure you switch back to your texture layer before you press delete, or nothing will happen. You can also use the drawing layer as a guide for the lasso tool to cut away the excess areas of the texture that you don't need. Repeat this process for the remainder of your drawing. You can experiment with a variety of opacities on each face. This will make it appear that there's a light source in the drawing, and you can use this technique to emulate shade and shadow in an environment where there otherwise isn't any. So again, the process for this step is make a copy of the texture layer, scale it down, adjust the opacity, and then use Distort to match it up with a face that you're trying to cover. The last step is to move all of the separate texture layers behind the drawing layer. This will help hide any mistakes you may have made in the trimming process. Congratulations, you did it. Awesome work.